Today we're going to explore the concept of pH and pOH in a solution. Water in its purest form is simply H2O. However, sometimes it actually can dissociate and split into its composite molecules. Specifically, it can split into H plus and OH minus. Another way of writing this is the two water molecules, can split into H3O plus OH minus. For our purposes of pH discussions, H plus and H3O, which is hydronium, are going to be equal. Okay? pH is actually defined as the negative log, now that's log base 10, of the concentration of hydrogen ions in solution. Okay? On the flip side, pOH is equal to the negative log of hydroxide ions in the solution. And based on the properties of water, based on the fact that if you take pure water at pH 7, so at pure water, pH equals pOH, which equals 7. If you take the concentration of H plus and you actually multiply it times the concentration of OH minus, you get 1 times 10 to the minus 7th. That's messy. Minus 7th. Okay, so this is where the sliding scale of 14 comes from. Okay, so what can we actually do to upset this balance? Why do we have acids and bases? Well, first off, what is an acid? Well, an acid is anything with a pH of less than 7. So what does that mean? That means we have to make it an acid, we have to increase our hydrogen ion concentration. So if we want to do this, we'll add something to water, like hydrochloric acid, which is HCl. And in this case, we're actually going to get H2O plus H plus Cl minus. Now, this hydrogen atom is actually going to bind with the water and make H3O, hydronium. And that, by adding a hydrochloric acid, is going to drive our hydrogen ion concentration up, and it'll drive our pH down. Conversely, if we have a base, or the solution is basic, the pH is greater than 7, that's going to cause anything that causes our hydroxide concentration to go up is basic. So in this case, we'll take something like potassium hydroxide, H2O, plus KOH, and add it to water. And there you'll get H2O plus K plus OH minus. So whenever our concentration of OH ions go up, that's going to cause our pH to increase, and our and the solution will become basic. All right. Like I said, some useful relationships are the fact that are written in green up here. Additionally, at all times, pH plus pOH is going to equal 14. All right. So do a small example. We need to find the pH of a solution. We're going to find the pH of a solution, pH of a 3.3 times 10 to the minus ninth molar OH solution. Okay. Notice I didn't give you the hydrogen atoms, right? We're dealing with POH here. So we need to find POH first. So we're going to find POH is equal to the negative log of our concentration of OH atoms, ions. All right, these brackets are molar. So molar molarity is equal to the amount of moles per liter, okay, which is denoted by a capital M or these square brackets on the outside. So the pH of our solution here, POH of our solution here, is negative log of 3.3 times 10 to the minus ninth. That is equal to 8.48. We're not done yet. Remember, this is the POH because we were given our OH ions to start. So therefore, we need to take 14, subtract 8.48 from it. That's going to give us our pH, which is equal to 5.52. So there is your final answer. Conversely, if you want to find the concentration of hydronium ions from our pH, we can do that as well. So what is now the concentration of your H plus ions? Well, that's simple. We know that the negative log of our concentration of hydronium ions is equal to our pH, which is equal to 5.52. We simply take 10 to the log of H plus. It's going to be equal to 10 to the negative 5.52, which is equal to 3.03 times 10 to the minus 6 molar. And that is your concentration of hydronium ions.